Hi all. So I've got a bit of a surprise for you today. It's alive. Yep, I've finally got all the parts for the controller, and I've set up a bench beside the table. Let me show you. Ooh. Yeah, it did its first steps yesterday. So I'm going to show you what I've got so far and let you know my first impressions. So let's have a look. Okay, so these two wires here are the wires from the power of the servo motor, and this here is the encoder wire, and this little gizmo here is a differential signal gizmo thing, whatever, which takes the signal from the encoder and makes it less prone to be disturbed by interference, basically, whatever. So so this can be a very long wire going through the machine, and it won't be and shouldn't be disturbed by interference. This goes straight into the servo drive. The power cables, one go straight to the servo drive, the other one goes through this coil here, just to smooth the signal. This here is the braking circuit for the servo. So when the servo stops quickly, it generates power, and this will dissipate this power. This here is a big ass transformator with many taps. I found 2 taps that give me about 92 volts. This is still AC, but now I'm going through this little capacitor bank and this diode bridge, which makes DC. I have this braking circuit here. Now back to the servo drive. It is a 160 volt, 35 amp servo drive, and it's quite cheap. I'll put the link in the description. And I was looking for servo drives for this type of brushed DC servo motors, and I found this, which was, as I said, quite not so expensive, and it's made by this company, CNC Drive. They also make this controller, and they make the software, which is called UCCNC, which we'll have a look at a bit later on. So the controller is connected to the computer via this network cable. What else? Just a little computer transfer for 12 volt and 5 volts. That's pretty much it. And I have this thing here, which I built for a different CNC project, but it's perfect for for my bench test. I'm glad I have it. It has all types of controls on it. You can choose your work. If you want to have your machine coordinates, DRO, your work offset, DRO, and your distance to go here. And also, if you press and keep it pressed, then you can put your X, you can set your X home, your X work coordinate, your to 0, your Y, and your Z. So there they have two different. This here is for the jug axis, so you can choose between the four axis, and this here is the scale. You see it goes up to an inch, which is was fine for a CNC router project, but not for this type, so I'll have to work on this, modify this, but for now, yeah. The MPG, this here is for feed override, so you can see the feed override is climbing here, and if I push on it, it goes back to 100%, and over here is the spindle speed override, and if I push on it, it goes to 100%. This, if I push, it starts the spindle. If I push again, it stops. And if I push and keep it pushed for, I think, 3 seconds, the spindle starts counterclockwise. And this is coolant on, coolant off, and cycle start, cycle hold, feed hold, I should say, and this is cycle stop. Of course, you know, on off and the kill switch. Now the software, this is UCCNC. Interface is quite nice, it's not bad. You have your G code here. If I zoom out, you can see this is my work area over here. Yeah, otherwise your G code is here. You can scroll it. You can edit the file right in here, which is nice. Rewind, close file, load file, blah, blah, blah. You have your probing, coolant, spindle, your feed override, and look at the feed override. I'll change it from my controller, and you see it it's changing it on the software. If I press on it goes back to 0. So yeah, and oh yeah, the jug is over here, and as you can see, if I change it here, it's changing over here as well. So it's all connected. What else? Well, you have your DROs here, machine, work, and distance to go, of course, and all the homing and stuff like that. Your G54 up to G59 here. Some, you know, just LEDs of what's going on. So right now, so it's idle, of course, right now. Okay, and then you have over here, I have to use the mouse. These are the offsets, the tool offsets, probing pages, which I haven't, you know, really played with yet, but yeah. These are the settings, so general settings, axis settings. Right now only the y-axis is connected. Spindle, I have pulleys are already supported by the software, so that's nice. The IO setups, the MPG, and all sorts of things. IOs again, IO triggers, there's tons of them. Appearance, and you can have different profiles for imperial, metric, plasma cutter, whatever. Okay, so that's about it. And anyway, I'll link I'll put a link in the description so you can download the manual if you want to have you know, a good look at it. But yeah, it's pretty good. Now, so that it's less jittery for you and more comfortable for me, I'll put the phone on a tripod and we'll have a look at the software while it's running a bit. Okay. Okay, so I moved the stuff around a bit so that you can see the screen and the controller at the same time. Right, so right now I'm in offline mode. I removed the reset. When the reset is on, of course, nothing moves. So now it's in offline mode. We can have a look at the interface moving without the machine moving. So I'll press cycle start here. Okay, now it's sort of waiting for the tool change. Since it's not set yet, it's just waiting. So here we go. Now the feed is very fast. This has about 4 inches by 4 inches, and the feed is 260 inch minutes, so which is pretty fast. As you can see here, it never really reaches the 250 inch. But yeah, otherwise that's pretty much it. If I feed old for a second, feed old like that, okay. And then if we have a look here on the X, why isn't that wait a second, just no, it's updating. Okay, it's on distance to go, that's right. Okay, sorry about that. I don't know if you can see, it's might be a bit small, but this is the distance to go right now. So there is only in Z, and it's, yeah, otherwise if I push here, now we're in work coordinates, so you can see these are the same. The DRO here is working, in short, and this is the machine coordinates. Yeah, okay, so let's keep going. And also my cycle start here is while it's working, if I push on it, it just activates the feed hold. So and pushing back on it starts the feed again. And if I push feed hold, as you can see, the spindle is still on. But if I press cycle stop, then the spindle stops. And if I press cycle start again, the spindle hasn't started, so I would have to start the spindle first and then cycle start again. Okay. What else? If we look at the diagnostics, you can see what's activated and what's not. It's running right now. If I push on cycle start, we're still in feed hold, but if I push cycle stop, then we're on idle. Then I'll activate the spindle and then start the machine again. We're in run. You can see everything is moving, and the offsets as well. Anyway, anything you would expect. Now it's changing. Whoops! It's changing tool. So it came back up and to the front of the table. So I can just and now it's changing tool, so it's just stopped for now. And now here we go again for the second that would be a ball mill, whatever. Okay, I guess it's should be time to have a look at the machine moving, maybe jog a little bit. So I'm gonna stop this, cycle stop, and I'm going to go to 0. The machine is in this position physically right now. So if I remove the offline mode, we should be safe. You can manually home the machine. So right now, that is in settings, general. The soft limit is on. So normally when I jog, I should not be able to go further than the machine limits. We'll test that right now, I guess. So I'll just change the position of the camera so that we can see ideally the controller and the machine at the same time. I'll try that. So let's try this. Okay, so this is the setup I came up with. You can see the screen, you can see the control, and you can see a part of the machine. So let's do some jogging. Okay, I'm not in offline mode. I'm not reset, so normally when I turn the MPG, the table is supposed to move. I chose the y-axis, and we are going into 10 thou increment. Yay! Can you see my happy face? Yeah, so that's jogging in 10 thou increment. This is in 100 thou. Well, I'll go back into 10 thou increment, and we'll see if my soft limits are working. There you go. And soft limits are working at the other end as well, of course. And now let's go into a 1 thou increment. And right now, as I said, there's a limit. I can only go with 1 thou increment unless I type it here, 0.0001, and I use the software interface to jog in, which is no good, of course, but just for now, works for testing, actually. Okay, this is it. This is 1/10. I have right now about 6/10 of backlash. Yeah, so what else? We could play some G-code maybe. So I'll just press cycle start, and we'll have a look at the machine working a little while. Let's go. Okay, waiting for my input. So what are my thoughts so far? Well, I've only played with it for since yesterday, and I'm not quite convinced yet. I don't know. It has potential. Maybe it's going to be okay. I don't know. I'll have to investigate a little more. I think I will go on and buy the two other drives and braking circuits. worst case scenario, I'll use all of this for the CNC router project and start over for this one. I don't know yet, but for now I have something I can work with. And it's not much of an investment, as you'll see if you follow the links. You'll see it's pretty cheap stuff. The fact that it's on a Windows computer is a bit scary. But it has some cool features like charge pumps, they call it. So it's a signal that the computer sends to the controller, pulse width modulation, very precise, and you can have like a circuit that watches this signal, and as soon as the signal is stopping for some reason, because Windows would, I don't know, make an update or whatever, you can use the signal to stop the machine. So that's reassuring a bit. And this software can be modified extensively. You have all sorts of tools. As you can see, I've paired this controller using Modbus, and I did like a month of programming to have this thing to work. But it works well, so it's quite promising. So I can, I have good hopes that I'll be able to create lots of all sorts of changes. Some of the things I'd like to add, just things I'd like to modify on the machine. One of the things is to add a button on the head, straight on the head, for a tool change, like, to have, to press a button on the control while holding the tool, I think is not such a good idea. So yeah, that is one thing I'd like to do. One thing I'd like to do also is in the tool changer, eventually, it's not the first thing I'll do, but eventually I'd like to put a servo motor for the carousel, so that when it's time to change, instead of having the Geneva gear, it would be a servo motor and belt and pulleys, so that I could change the tool very fast, like, and then take the next tool. That'd be nice eventually. Rigid tapping, I'd like to add that. That would be great. Of course, I'll have to install a limit switch on the machine. What else? Oh yeah, one thing I'd like, I've been working with CNCs for a while, and the coolant dripping on my hands while I'm doing my setup after, while I'm removing the parts. It's these little things that get annoying, and I thought actually I've been talking with a friend, and I also saw that the at least of I know of machine I know that do it. The Kern does it. I've seen it with while watching John Grimsmo channel. When the coolant stops, you have air blown through the coolant nozzles. So I guess I would have to install a one-way valve on the coolant, and just after the one-way valve, an intake or outtake, whatever, of air, and a solenoid valve. As soon as the control sees an M9, it would stop the coolant and shoot air for, let's say, 2 seconds or whatever through through the nozzles to flush all the coolant. That would be very nice. Otherwise, I want to make a nice control box with just the screen and the keyboard, maybe a trackpad. I'm used to using trackpads, so maybe a trackpad, or I don't know, and all the control buttons. This little LCD would go, but otherwise these controls I think are very nice. Yeah, stuff like that. I'm thinking actually of redoing the whole sheet metal enclosure from scratch. I'd like to have maybe the coolant tank accessible from the front, pulled out from the front. So it would have 2 tanks on each side and just a passage in the front, maybe, so that the coolant can go across. And the coolant tank, I have like you know, ideas of ways to have all the oil, a little pump. This is the main pump that shoots the coolant, and a small, can you see? Yeah, I think you can see. A small aquarium pump that would take the coolant, throw it in this bigger space so that all the oil would move towards this area, and then have an oil skimmer. Yeah. Anyway, these are all thoughts. I don't know if I'm going to do them or not, but these are all ideas. I'd like to have maybe a web interface. This is stuff I can do. I've done it before, so yeah. Anyway, so that's pretty much it for this one, I think. I guess I'm expecting a lot of comments on this video, and I'm open to suggestion. If this is not working, I'm thinking of going towards Linux CNC, but yeah, I haven't I'm still trying this for now, and we'll see if it's working or not. Yeah, what are your thoughts? What do you think? Suggestion, whatever. I'm still quite open to suggestion. Centroid, really nice, but maybe a bit out of my budget for now. So, but maybe I won't have any choice. Maybe I'll have to go this way. I don't know. You know of better drives? Eventually, I'd like to have AC drives and AC servos. This is one thing I'd like to do eventually. I think, you know, they're faster and yeah. So thanks for watching till the end, my friends, and we'll see you on the next one. Bye. Oh, and another thing I'd like to add is a chip auger on the machine. So if you hear of, you know, if you see a screw, someone that has a screw that doesn't want it anymore, or a good deal, or you find one in a scrapyard, whatever, about 10 foot long, let me know. I'm interested. This is one thing I'd really like to have, is a chip auger on the machine. Yeah. All right.